Okay, hello again and welcome to Thermodynamics in Food Processing FS152 Module 3. Ngayon ay February 17 and it's almost 5 in the morning. Medyo malamig na Wednesday morning. So before we start, I hope you have copies of your steam tables with you, either the one provided, which is an appendix from Singh and Heldman, or maybe anything you could find online. Of course, there will be slight differences in the tabulation and even yung format ng table, but they're all generally useful and should give answers within plus minus a few percent of each other. Okay. And so just to give you an idea, these are the sample problems which we may need to use the steam tables to solve. So tingnan niyo muna sila ngayon and observe because later on babalikan natin as we mapagpapracticean natin itong mga to para matuto tayong gumamit ng tama ng steam tables natin. So take note that there are many different units for pressure and you would therefore have to convert them before you get to use. And of course, sometimes in steam tables inyo, they have their own quirks on anong units ng pressure ang gamit nila or even temperature. Okay, since we'll be dealing a lot with pressure, it's good to know no, yung different terms na ginagamit. So here we have a few terms that we use. So we have gauge pressure, vacuum pressure, and then the difference between the terms ng absolute pressure and the atmospheric pressure. So when we say absolute pressure, no, yan yung, kasi di ba pag sinabi natin atmospheric pressure, obviously yan yung pressure that we're exposed to in the atmosphere. But whenever we have a vessel that has a different pressure, then that vessel has a measurable absolute pressure. So tulad halimbawa ng when you have a pressure canner, yung pressure dun sa loob ng canner mo is different from the atmospheric pressure because it's separated physically by a barrier. At the same time, if you have a car tire or a bicycle tire, the pressure in that tire is different from the atmospheric pressure and yun yung typically absolute pressure na tinatawag natin. Ngayon, gauge and vacuum pressures are just terms to denote the difference between atmospheric pressure and absolute pressure. Typically, that we use gauge pressure kapag mas malaki yung absolute sa atmospheric, aka sa loob ng iyong pressure canner, you have a pressure gauge. And generally that pressure gauge displays how much it is above atmospheric pressure. So in this case, for example, if your atmospheric pressure is 14.7 psi, the gauge pressure displays how much the absolute pressure is above the atmospheric pressure, such that when the atmospheric pressure and absolute pressure are equal, the gauge reading is 0. So when you have actually a gauge reading of 21 psi, then that means the absolute pressure is 21 psi higher than whatever the atmospheric pressure is. By the way, take note that atmospheric pressure is dependent on, well, among other things, elevation, such that if you have a gauge pressure of 21 psi in Baguio versus a gauge pressure of 21 psi in Quezon City, since the atmospheric pressure in Baguio and Quezon City are different, then that also means the absolute pressure in Baguio and Quezon City are different for them to have the same gauge reading. Okay, vacuum pressure on the other hand is just, it's a term used now when you have absolute pressure that is lower than atmospheric pressure. Suffice to say, we use the term vacuum whenever we deal with pressures lower than atmospheric pressure. So if you've ever used the vacuum oven sa lab, sinisip-sip niya yung hangin para mas mababa yung pressure sa loob ng vacuum chamber, yung absolute pressure, and therefore vacuum gauge readings just tell you how much lower than atmospheric pressure the absolute pressure inside that chamber is. Given these law equations, of course, we note that gauge pressure is equal to the negative of vacuum pressure. However, in reality, this, of course, does not make sense kasi both pressure gauges, the normal pressure gauge and the vacuum gauge, are often used separately on pieces of equipment that are either designed for higher than atmospheric pressure or lower than atmospheric pressure, and therefore usually start sila sa zero. Okay. But anyway, just to know the correlation between them. Now again, on the discussion of steam tables, the absolute pressure, yung typical na name nung column na yun, in our case sa Singen-Heldman, it's the leftmost column, is the pressure at which water will vaporize at that corresponding temperature. So actually, if you look at it for 100 degrees Celsius, the absolute pressure there is equal to the typical atmospheric pressure. Then that is to say, at a regular atmospheric pressure natin, your water will vaporize at 100 degrees Celsius kasi as we know, yung pag-vaporize ng isang liquid is all a function of the pressure it is exposed to, and that is why, if you've heard before, di ba, sa Mount Everest, kumukulo yung tubig at around 20 plus degrees Celsius, and therefore hindi sila makaluto ng itlog doon unless they use a pressure cooker type of thing kasi kumukulo yung tubig pero mas malamig pa siya sa katawan mo, and that's not enough for the eggs to denature yung proteins. Alright, and that is why the boiling water in Baguio is a few degrees Celsius colder than the boiling water in Quezon City. Okay, now you have enthalpy of liquid. So I hope you have your steam tables beside you, no, para makita nyo. Depende kasi sa steam table, iba-iba yung mga pinapang-denote nila na symbols, no. But as we've talked about before, what enthalpy is, it's a reference point to the internal energy, specifically heat content of, well, in this case, water, with respect to 0 degrees Celsius at a certain temperature, regardless of pressure. So typically, when you have basta liquid water siya and it's at that temperature, same yung enthalpy niya. Whether ikaw ay nasa Baguio or nasa Quezon City, hindi mo kailangan isipin yung pressure basta as long as liquid siya. Okay, pero pag steam na siya, ibang usapan na yun, of course. Okay, the enthalpy of evaporation, or HFG in some cases, refers to the heat absorbed by saturated liquid to turn it into saturated vapor. So if you remember yung graph natin na pinakita last time, yung may blue lines, pag ganun, yan yung long vertical line. So that means, yun lang, that's how much heat it needs to absorb to turn into saturated vapor. And at the same time, that is how much heat it can give off from the saturated vapor state until it condenses to the saturated liquid state. And the importance of this one is, of course, we use this in our calculations whenever you have steam condensing and transferring its energy to the food being heated. Ito yung ginagamit nating value, okay, to determine that. Enthalpy of saturated vapor naman is the heat content of water vapor with respect to 0 degrees C at the corresponding, take note, temperature and pressure. So at this case, pag vapor na pinag-uusapan, pressure dependent na. So even at the same temperature, the enthalpy would differ if the pressure is different, or rather that it would be at a certain pressure at any given time. So anyway, Ang enthalpies kasi is initial and final states yan. Usually when we consider enthalpy problems, we consider the initial and final state and use these points to compute for the change in enthalpy. So for example, if you heat water from 30 degrees Celsius to 90 degrees Celsius, to get the change in enthalpy, you just subtract the one enthalpy value from the other, and you have to determine those using the table, sometimes in interpolation. On the other hand, if alam mo nga how much heat would be transferred um, in the process of using steam to heat this food product, then you have to look at the initial state and the final state of the heat transfer medium or liquid mo. Nag-start ka at sa steam with this temperature and this pressure, and then you ended up with liquid at this temperature and pressure, and then you just compute those values and subtract from each other. And ang use nito, of course, is to determine papaano mo could determine how much steam you will need, for example, to process a certain volume or weight of your product. Okay, so steam quality, as we mentioned before, di ba, ay ito lang kung ano yung proportion ng saturated vapor doon sa iyong vapor liquid mixture. So typically, there are times where in the steam you produce is actually a vapor liquid mixture, and therefore yung enthalpy niya would be between the enthalpy of saturated liquid and saturated vapor. And for you to compute the steam quality or how much saturated vapor there is, then you just use this equation where H is the enthalpy of the vapor liquid mixture, and that is determined by the 1 minus the steam quality multiplied by the enthalpy of saturated liquid plus the product of your steam quality multiplied by the enthalpy of the saturated vapor. So we can just rearrange this equation depending kung ano yung given and unknown mo to get the possible value. Typically, yung HC and HV are tabular values naman, ano? And yung H is pwedeng given siya or pwedeng siya yung hinahanap mo. Ngayon, ito naman yung isa nating problema pa. When you are looking for values that are between any two steam table values, you would have to use linear interpolation. Ngayon, actually online, meron mga steam tables that could, hindi na pala sila tables, no? Parang search bar lang, you input the values and they calculate for you. Siyempre kaya nauso yung steam tables dati dahil wala pa naman yung mga calculator natin, manual. And then what people would do is use those tables to calculate for values in between. No? Like what if ang increments ng temperature mo is 3 degrees lang, 3, 6, 9 degrees Celsius, and then pinapahanap sa'yo ay 7 degrees Celsius na value. So you have to do linear interpolation. Now, linear interpolation is something you'd probably done with your algebra or trigo pa lang, ano? Kasi ang basis naman nito is the slope, the rise over run concept. And when you have 2 points, they form a line. And to get the point anywhere in between that line, you do an interpolation, as can be seen in this equation. Okay, where your y sub u and k is the unknown. Delta y over delta x lang naman yan. So you just have to rearrange your equation depending on what values you have there. Of course, the y's and the x's here, sa table mo naman dadalawa lang yan. You either use the reference temperature, and then you may have an unknown enthalpy value. So usually pag binigyan ka ng problem, ang known values mo dyan, una, lahat ng tabular values mo for temperature and enthalpy. And then usually you would probably have a unknown temperature value. Tapos ang kailangan mong hanapin is yung enthalpy at that temperature. No? So you just input into this equation and rearrange to isolate whatever yung value na kailangan mong makuha. Okay. Alright, so let's try a sample problem. So in this case, you are to find the enthalpy of saturated vapor at 130 kilopascals of pressure. So you can actually use any two columns other than the temperature. In this case naman, yung temperature at pressure ay nakatali yan sa isa't isa. So we find the pressure values that sandwich 130, which from your steam table would be 120.82 and 143.27 kPa, corresponding to 110 and 105 degrees Celsius respectively. So in this case, we can use pressure instead of temperature values kasi nga pressure naman yung isang given mo kesa mag-interpolate ka pa to determine anong ilang degrees Celsius ang katumbas nito, no? Anyway, so yun. Then you have to rearrange this equation to isolate your unknown, and then you have that, and we just have to fill in the values since your unknown is enthalpy. So your y are enthalpy values and your x are your pressure values. Okay, so we just input everything. So sa steam table, makuha na natin yung enthalpy values corresponding dun sa 120 and 143 na kPa. So we just need to input them in the proper location, denoting na magkatali sila yung x sub 1 and y sub 1 would have to be yung nasa isang row ng table na values for pressure and enthalpy respectively. And of course, this is just plug and play. To check your answer, if your answer is correct, the y unknown should obviously be in between the two known y values, no? Kasi nga nag-interpolate ka sa pagitan nila, and 286.9 is in between 2686.9 is in between these two, so tama naman. Okay, there's also a separate table for superheated steam. Remember that when you have superheated steam, yung pressure at temperature niya ay medyo independent na sa isa't isa. No, unlike sa liquid na alam natin na or rather sa saturated steam na naka-fixed yung pressure value dun sa temperature at which siya dapat mag-evaporate. So superheated steam, yun yung mahirap. So whenever the problem calls for superheated steam or any steam above the saturated vapor temperature, then we have to use this. So H is the enthalpy or total heat content, still with respect to 0 degrees Celsius of steam for a specific temperature and pressure, kasi nga ang enthalpy pa rin ay galing doon sa temperature reference point. Okay. Ngayon, ang problema dito, kapag hindi bumagsak doon sa superheated steam table mo yung temperature and pressure na nasa isang problem or sinasolve mo, you need to use double interpolation. Ooh, okay, ano yan, sir? Ito lang naman yung example niya. You use the same equations, pero you have to interpolate 3 times. Bakit nga siya double? Nakakung 3 beses pala para makuha mo yung sagot. So for example, I've crafted this table for you. If you were to find the enthalpy of superheated steam at a temperature of 60 degrees Celsius and at 200 kilopascals, so based on your tabular values, you would first have to interpolate here for 150 degrees and 200 kilopascal, and then for 200 degrees at 200 kilopascal, kasi itong dalawa parehas, halimbawa wala dun sa table mo, para makuha mo ito, na-interpolate mo naman using these two new enthalpy values that you were able to solve, and then this temperature and pressure value. Okay, so same deal lang yun, just have to repeat it 3 times, and a bit more confusing kasi every every time yung equation mo, iba na yung y unknown na ginagamit mo. Okay, so for that problem, ito naman yung supposed to yung makuha mong values. Of course, since this is interpolation, we're expecting a certain margin of error no, in your answers, lalo na kung error propagation. So medyo maluwag naman ako doon. And at the same time, if you're using a different steam table, then maybe iba din yung increments niya. Like yung iba 5 degrees Celsius, yung iba naka Fahrenheit, so yun. Okay, so in problem solving, the energy gained or lost is equal to a difference in enthalpies between initial and final states. So regardless of the number of transitions. Yung iba kasi sa inyo, sanay na mag-compute, I'll approach this using the MC delta T method. Tapos kapag meron siyang phase transition from liquid to gas, meron kang heat of vaporization multiplied by the ilang kilograms ng liquid. So hindi niyo na po kailangan gawin yon. You just have to know ano yung enthalpy niya dun sa final state, ano yung enthalpy niya sa initial state, and then you subtract those two values. Lahat halos ng enthalpy problems sa using steam tables ay ganoon ang approach. And typically, we only use the specific heat values if we're dealing with substances other than water. Like, syempre, kung halimbawa, heat transfer, yan, no, nag-init ka ng food product, then you have to have an energy balance. So, the heat lost by steam should equal the heat gained by the product, the food product. And that's where you do your specific heat calculations, MCAT na yan, okay?